we are going to model a City Multi VRF system. Starting with the calculator spreadsheet, this is the output report that will be printed to the notes to the energy modeler. This contains all pertinent information associated with the VRF heat pump that the energy modeler needs to account for when modeling. So these are items that we cannot model directly. It's based on the energy modeler's project, and they will have to modify these fields themselves. That said, we have a short cut sheet for the equipment, and then these are all automatically generated performance curves in comparison to the EnergyPlus default performance curves. There are 5 input tabs that need to be modified to calculate everything in the spreadsheet. All of these other tabs are just calculations, and these derive all of their data from these 5 tabs that we need to input. Starting with the OSM input tab, you will see these are all the calculations. All of this is auto-generated based on these green fields. So all we have to do is modify these green fields. In this tab, modify the green fields in this tab. Actually, these fields are derived from this table. So we'll get to this later. And then this tab, there's also some green fields that need to be modified. And this tab as well, need to modify these green fields. Everything else is auto-calculated, and these do not need to be modified, just the green fields. Same with the cooling tab, these green fields. And then once all of those green fields have been modified, everything is auto-calculated on the OSM input tab. And then we will copy and paste these red fields to an OSM file, and then input it into an OpenStudio library. So with that said, let's begin. It starts with the specification cut sheet, and this can be found in the City Multi data book. We will be modeling the 144. That's going to be this one right here. And what we can do is just copy this page to a snapshot, paste it, and we're just going to overlay it over the top of this one here. And let us send it to the back. This is the older one. This is the previous one we modeled, the EP120. We're going to delete this. So now we have the EP144. We'll just adjust this to the correct parameters. And then it's as simple as typing in these values. So 40.4, 12.72, 12.70, And then the next step is to bring in this cut sheet. This can be found in the submittals. Let's see, it's going to be in the folder. Each one of these modeling objects has its own folder with performance curves. So we'll open up the submittal for the EP144. We'll copy this page to a snapshot and paste this in here. And something like this. Something like this. And we're going to send this page to the back. And we will select the 120, the old 120. We're going to delete it. So now we have the 144. And again, just adjust this to this. And again, we need to input the data. So it's 15% to 100%. 15% is already in there. How many compressors? This has one scroll compressor. So this is already one. And that is it for this page. Let me see. Yes, that's it for this page. So the next page we need to go to is, let's start with the cooling page. So first thing we need to do is edit the first green field. So PUHY, and then it's going to be a 144. This can be taken from this specifications cut sheets, but in particular, it's also on this curve sheet that we're going to copy from the City Multi data book. So let's go to the City Multi data book. And we need to search for the EP144. Performance curves. And that's going to be this one right here. So the first curve that we need to edit, well, let's see. Let's drop in the whole sheet first. So we're going to take this sheet and copy the snapshot. And we're going to paste this in here. And we will send this to the back. And we're going to take the old EP120 and delete it. So now we have the EP144. So with that said, we need to change this this field. It's going to be EP144 TNU YNU. And then you need to change the rated performance values. This is going to be 144,000. The cooling is going to be 42.2. The input is going to be 10.63. The next step is to take the next curve and input these values. So I use a curve input algorithm. Let's see. It's going to be plot digitizer right here. I have purchased the plot digitizer software so I can use it on my computer. But if you want to, you can use the plot digitizer online. If we go to plot digitizer and just open up this link, plotdigitizer.com, and click the free online app. So plot digitizer just takes an image, and then you can extract data points from that image. So we will be taking this first image here. This is going to be the indoor unit temperature corrections from this chart right here. So we have already, let me see, EP 144. I think I have already, yeah, I think all of these charts are the same. And then if I can remember correctly, yeah, this was the EP 120. It has the same chart. Same as the EP 96. So all of these charts are the same. So we can just use the same data from the previous project for this one. So this is good data. We'll just keep this. We'll just keep this chart. Moving on, let's take a look at the next chart here. This is the ratio of cooling capacity as a function of outdoor dry bulb temperature. So that's going to be this chart right here. And I believe I have already copied this chart to an image. It's going to be this right here. No, this one's, oh yes. Yes, it's the same one. But what you can do is just simply copy the chart. And so what I do is just do a screenshot and just do this, copy, and then paint, paste, crop, and then save this as a PNG picture. And that's what you're going to be doing with all of these curves. And we will just save this as cooling capacity ratio function of outdoor dry bulb temperature. It's going to be this one right here. I'm just going to save this. I'll just save this as this file. And we already had it saved, so it's just going to replace. Okay, now that we have that input, or now that we have that image, we're going to drop that image onto the plot digitizer. Let me see here. Let's just copy. Well, maybe I can drag it on here. Yes. Right. So we've dragged that onto the plot digitizer. We want to locate our primary axes. And so here's the x1, that's the beginning of the x-axis, and then x2 is the end of the x-axis. And you can see up here in the right, there's sort of a magnifier. It's quite helpful to accurately locate the axis. It doesn't have to be exact, but just pretty close. And then we're just going to drag these over here. So this is the primary x-axis. And again, we're going to do the same thing for the y-axis. y1 and then y2 is going to land up here. Right. So the next step is let's take a look at our spreadsheet. So we've got 1, 2, 3, 4 data points, and those are going to be 1, 2, 3, 4 data points. And normally you want to put these data points where there's a change in direction of the curve. So we can take a look at this here. There is a slight bump in the curve right here. So that would, but it's basically linear between these 2 points. So I don't think we need to add that here right now. Later on, we might have to add that, and if that's the case, we would have to add one more data point to this, which means modifying the tab that's associated with this. But for now, let's just do the 4 data points. So we're just going to click, let me see, the data points start at -5. So that's where we want to start, -5 here. So we'll just do this one here. And again, it doesn't have to be exact, just approximate. This one here, and this one here. The other thing that we need to do is assign the data points starting and ending points. So for x1, it's starting at -5 Celsius. So we'll type in -5 here. For x2, it goes up to, does it go up to? X2 goes up to 52 Celsius. It's going to be 52 Celsius. For y1, it starts at 0.3. And for y2, it goes up to 1.3. Right. So now that we've assigned all of those and we have our data, these are our data points here, we can just copy to the clipboard, go back to our spreadsheet, and then paste these values in here. Oops. And if you find that those comma separated values are pasted in as delimited values, you can use a text to columns function that, for example, Excel has. And once you use the text to column in Excel, you can select comma separated and then finish. And then that'll split those into the two columns. And then from then on, I think Excel automatically assumes that you're pasting CSV values. So after you do that, the next ones that you do, it'll just automatically paste those. So if we go back to this and copy the data again, and then just click paste, it pastes that information in there. The other thing that you need to keep in mind is that these must be in ascending order, and that's what we've done with our data points. So we started at -5 Celsius, went to 20 Celsius, around 46 Celsius, and then 52 Celsius. So when you're adding these data points in the plot digitizer, you need to make sure that they're in order and they're in an ascending order. And if they're not in ascending order, what you can do is just do a sort function, and you would sort by the x values and make sure that it's smallest to largest. But we already have it sorted, so it should be fine. And then what I like to do is just do a screenshot of this plot just for reference. We'll just do this here. And we're going to paste this into the spreadsheet. And we'll have to modify this so that it's the right size and approximately in the right location. And then we're going to send, let's see, send to the back. And then this old one that we had here, we're going to delete it. And we're going to have to send this to the back as well, so we have the new one in here. Right, and so that that records our data and the proof that we did the calculation. Moving on, let's take a look at the next curve. This is the energy input ratio modifier as a function of outdoor temperature. And that is also going to be in our cooling energy ratio modifier. So it's going to be this one right here. And it's helpful to put some guidelines on the plot. And that's what we've done here. We put some guidelines on the plot. So these guidelines, you can see, so there's a node right here. And because there's a node here, we need to make sure that we record the data for each one of these curves at that same node. And again, there's a node right here. So because there's a node here, we also need to make sure that all of these other data points are recorded at the same outdoor temperature, and that's the x value down here. Likewise, there's a node right here where the plot changes direction. So because there's a node there, we have to record these data points on all the other plots as well. So that's why I've put those guidelines in there. And this is going to be, you see, the same curve, right? So yeah, so it's the same process. You would just take a screenshot of this, save it as an image, and then we would drop the image into the plot digitizer. So let's just go to new, or open a file. I guess, yeah, we can open a file. And we're going to copy this path and paste. And again, it's the same process. You're going to have to locate the x and y values. The Mitsubishi curves You can see these go in order. So the 23.9 Celsius wet bulb temperature curve is this one on the top, and then it goes to the 22 Celsius curve, and then all the way down to the 15 Celsius curve right here. So that's going to be on the bottom. So that's what we'll do next. Go ahead and add these data points in here. Right where it intersects with the curve. Again, it doesn't have to be exact, just approximate. And the last one is down here. And those are all in ascending order. And then we can just copy from the clipboard. We should have the same number of data points. So we'll just do a paste. And yes, we've got the same number of data points. And then this is the 15 Celsius wet bulb curve. So we would just copy and paste this in here, just like the last one. And paste it over this, just for references, and make sure that we, well, proof that we did the calculation. So, be this here. And we'll just send this to the background. We're going to delete the old curve. And we're going to bring this bring it to the front. Oops. Actually, let's bring this to the front first. Bring it to the side. And we'll bring this to the front and cut and paste this right here. So that's the 15 Celsius curve. And the process is the same for the rest of the curves. So what I like to do is just continue on with the plot digitizer. So these can be just adjusted. So we've already got the data points on the digitizer, and we're just going to be doing the 16 Celsius curve next, which is going to be the one right above it. So you can just grab these data points and move them up. And that just automatically changes the values. Again, it's nice to use this magnifier up in the top right. And there's our values again. And it automatically updates the values. So copy, and for the 16 Celsius curve, we're just going to paste it into here. And again, the process is the same. We'll do a screenshot and then paste it on here, update this, and move on. And that's what we have to do with basically all of these curves. It's all the same process with these curves. So the next step is the capacity tables for the EP144. They're going to look like this. So we will go back to the City Multi Handbook, and let me see. Let's do search for EP144 again, and it's going to be not on the next page. The next page is the heating section, so it's probably going to be this one right here, capacity tables for this is high heating performance, I believe. Right, here we go. These are the capacity tables as a ratio of the indoor unit capacity. So that's going to be these tables right here. So the previous one we did was an EP120. This time we're going to do the EP144. So let's just go ahead and take a screenshot of this. And we will drop this in here. And approximately the same size as this one. I'm going to send this to the back, and we'll delete the old one. And again, so this is a table that will be used on the plot digitizer. And so we'll just open that one up. Let me see. Yeah, so it's going to be this one right here. Save this as a screenshot. Again, it's the same procedure to set the X and Y values. This one, it's good to have both of these plots on the same image, because then you can just if you already set the X values are going to be the same for both plots. The Y, we will set it at this one here and this one here for now. So X is going to be 50, and then X2. In fact, what we could do is just, this plot doesn't even go past this data point, so we can set this at 190. Y1 is 0.2 and Y2 is 1.2. And the singular plot that we have for this data is going to be just 1 point. And it's going to be this point right here in the cooling mode. So we'll drop that on there. We'll copy it and paste it to the spreadsheet. So that's that one right there. Just gonna adjust that. The next one we're going to do is the total capacity. Let's see, this was capacity as a ratio of capacity. This one's a capacity as a ratio of with a ratio of input. So that's this one here. So it's the same thing, but this time we're going to move our data points down to here and do this other plot. And make sure to adjust the Y values. Again, it's 0.2, and then this one, oh, it's the same, 1.2. So those are good. So our first plot here is actually going to be down here. We're doing cooling, so it's going to be this plot here. And it looks like for this we have a total of 6 plots. And it looks like they're on just the table values for capacity. So we'll just do those 6 plots. One right here. There's one right here. 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 And just keep in mind we're doing cooling. It's going to be the solid line here. All right, and those should be in ascending order. We'll copy this and again paste it from the clipboard. And then I've got a note here. It says for Mitsubishi, this is the same curve image for heating. And it's recommended generating the heating curves now before you move on. Well, we have it still in the digitizer. Right, so before we move on, let's take a snapshot of this curve here. And just do this. And we can drop this into here as proof that we did the calculation. Maybe something like this. And this is in cooling mode. So we just want to make note that this is in cooling mode, right? So with that said, let's go to the heating tab and do the same thing for this curve. Let me see, this curve is high heating. No, just the regular heating tab, sorry. Go to the regular heating tab, and that's going to be this table here. Again, it's the same procedure. So we'll do the capacity as a ratio of input first, since we already have those values on this table. So let's just move these values up for heating. And those are the heating values, and we can copy and paste these into the heating tab. And again, we will just print as proof of calculation. And we could save some time here without doing this, but it's important to have proof of calculations. Heating. And let's see. Heating. Right, and then we also need to make sure we get this data point right here for the ratio of capacity. So what you can do, if you want to delete these data points, you can just do a right click on these and delete these. And we're just going to move this data point up to here for the heating. And again, we need to move these Y values because we're dealing with this table up here instead. 2.2. So that should be good. And then we'll just copy and paste this onto the heating tab. So that's those values there. Let's go back to cooling, and then the next step is to do the cooling capacity correction as a function of combination ratio tables. Those tables are again found in the City Multi Handbook, and that's going to be these tables right here. Again, we have these tables sort of screenshotted onto our folder, so we'll just open that file, and that's, let's see, it's gonna be this table here, EP144, and the procedure is the same. So we need to adjust the axes. The first curve that we will be looking at is the indoor unit capacity at 72,000 BTUs. And we'll just drop in the data points. Sometimes you have to drop it in and then drag it over. And it just goes right along here for 72. Just like that. And then copy and paste the data points. And the procedure is the same. Well, let me see. Let's copy and paste as proof of calculations. Oops. What did we do? What's over here? Going to be here. And something like that. Delete. And we're doing the 72,000. So we need to make sure that this is 72 right here. And the procedure is the same for the other ones. For the 108, you can see it sort of goes along and then it dips down right here and it goes the final data points here. So keep in mind as you go along for 144, it dips down and then we have to follow these guidelines down for the other data points. The note is need to make sure that we are using the correct units. So EnergyPlus always uses metric units. So when you're calibrating the tables, we need to make sure that these axes are using the metric units, except for these, of course. So these units are in BTUs, and these are actually calculated on the spreadsheet as BTUs, but then they're converted to a ratio, which is non-dimensional for the final input. So these we will keep as imperial units, but for the data points on the table, those X values need to be metric. Moving on to the heating tab, it's the same process, filling in this data. This table or this chart does change, so this will have to be digitized and input those data. This is the same process as cooling, and then this one we had to add, I think, a couple of extra data points on this one. The more curves that are in the curves, the more data points we need to capture that information. So as long as it's linear in between the points, that's fine, but we need to try to approximate that as much as possible. So that's something to keep in mind. This is the same process. This is just one data point. Same with this one. And then this one actually shares the same chart with the EP120, EP144, and the EP168. So this data will remain the same. And then finally, with the defrost, there's a note here telling you what to do. We have an EP144, and so if we go to the defrost tab, you can see that EP144 is on line 13. So all of these points in here, I've already changed them, but you can just select it and do, well, Control F to find. And so it used to be 12, and then I made it 13. But so what you can just do is search for 12 and replace with 13, and then replace all. But I've already replaced it. So, and that's as simple as that with the heating tab. So moving along, we need to go to the high performance heating tab, which is H heating right here. And again, the process is the same. However, you need to note that it should say high heating performance mode in the City Multi data book. So we can go to search again and EP144, and so we need to search for the high heating performance. This is standard heating. This is cooling. Here, right here. So this is the high heating performance, and it says right at the top here, high heating performance. And you'll note that these tables are a little bit different. In particular, this table is a little bit different than the standard heating performance chart. But all of these are. So with the exception of this one should be the same, and there's no need to do that anyway. So the digitizing process is the same. It's just inputting the data for the high heating performance mode. Okay, the next step is to go to the OSM input tab. And there are a couple of other items in here. It's these green items here, and these will not be applicable to the regular heat pumps, but they will be applicable to the heat recovery heat pumps that we get to later on. And we'll have to save that for later. So this is always going to be no for heat pump waste heat recovery. So the next field is this one, ratio of first stage compressor to total compressor capacity. And it's going to be this field here. And so with the Mitsubishi equipment, it looks like all of these only have one compressor, but they're composed of like 3 different modules. So this one, for instance, has one compressor, and one compressor. This compressor actually happens to be smaller than the others, but I think what we can do for simplicity is just do just a simple ratio. So so 1 over the total number of compressors. So for that example, it'd be 1 compressor out of 3. And just assume that the compressor size is the same, mainly because this is only used for computing crankcase heat energy use, and the Mitsubishi equipment doesn't use crankcase heating. It uses hot gas bypass. And then the final field is reverse cycle. And the Mitsubishi equipment uses reverse cycle for defrost, so this shouldn't change. The other option is resistive. That's if the equipment has resistive heat for defrost. But for Mitsubishi, this is just going to be reverse cycle. And that is all for the green fields. The next step is to copy and paste all of these red fields into a library file template. So it will be this one here. We'll just open this up, edit width and text editor. This is just basically a shell OSM file. It has very little information in it. And we'll paste it in here and we'll save this. Actually, yeah, we will save this as, oops, no, we don't want to do that. Let's save as, and we can just save it as the we'll just save it as the 144 library file. And the next step is to open up that library file right here with OpenStudio and make sure that it opens up correctly. So yes, the model got updated. Doesn't look like there were any errors. We can check to see our VRF systems in here, and it looks good. And we can do Control S for save, and that saves it. And then we can use this to import into any of our projects or into the master Mitsubishi library file. So that is how you use this spreadsheet. Basically filling in all the green fields and digitizing the curves. And then the final step is to go back to the Assumptions tab and make sure that these have been updated to the correct model numbers. I don't think that there's going to be any changes to this information based on the models. That's something just to keep an eye out in the Mitsubishi data book. Copy and paste in the cut sheet and just double check that these curves are complete and they're not sort of missing information. And then, yeah, the final task is to print the sheet. And save it to the Notes to the Modeler folder as a PDF. So that covers the procedure to generate the performance curves for the Mitsubishi equipment. Since I did this video a little while ago, I've made some streamlining changes to this. And so I've marked these, each one of the steps with numbers, and I've placed the curve images in a download file that you can download for an example. And so you'll note that the curve images start with a number 0, 1. So that would be this curve here. And so that's the curve that'll be digitized for this data. Curve number 2, likewise. And same goes for heating, high heating, and for the basic performance input data. So I will post these in a download folder that you can use. If you do find that you're generating some of these performances, feel free to send them over to me, and I can upload those to the building component library. Or if you wanted to create your own repository and upload those to the building component library, that would be great as well. I'm sure the energy modeling community would appreciate it. All right, thank you. Please like and subscribe.